Hello everyone, I'm Dipannita, your TA for Fundamentals of Electrical Engineering course of NPTEL. Welcome to the ninth interaction session. You have been taught about the three-phase circuits in this week. So we will be solving a few problems based on three-phase network. So we have our first problem in which a three-phase, three-wire system which is star connected is given, in which the load resistance is given in like from each line to the neutral, that is in each phase the resistance, the inductance and the capacitance are given. It is assumed that ABC phase sequence with 400 line to line voltage at 60 hertz is there. Find the total power watts taken by the load. So this line to line voltage means the line voltage is given, and in each phase how much resistance, capacitance and inductance is there, it is given, and it is said that it is a star connected load. We have to find the total power that is consumed, that is I phase, V phase for each of the branches, and then summation of all of it. So the information that you were given here is it is 60 hertz. So frequency is given as 60 hertz. So sorry, this is omega. So you have to calculate 2 pi f, which is equal to 2 pi into 60, 120 pi. This is in radian per second. Now we can find the impedance of the source for each phase, right? So let us because in order to calculate the current we have to know what is the impedance, because we have the phase voltage, we do not have the current. So let us find the impedance. Z will be equal to uh, 75 plus x j, this will be j omega L, right? J
Yes, ma'am.
omega L minus 1 by j omega C, right? So it is 75 plus j omega, we have it is to be 60, right? So let me take the calculator.
Yes.
Yeah. So the frequency is given here. Sorry, I have written f by mistake. The frequency is given here. Calculate omega. Omega is equal to 2 pi f. So this is 2 and 120 pi. L is 125 millihenry. 125 10 to the power minus 3 minus uh, so this is j omega c. So just this is just bring the j outside, so it will be 1 by
Omega.
yeah, 120 pi into 55 into 10 to the power minus 6. So just calculate this. So j, let's calculate it. So 120 into pi into 125 divided by 10,000, it is 15 pi, so it is 47.12, 47.12 minus 1 by 120 into pi into 55, 10 to the power 6. This is
Mine,
40. Yes.
that is 471.2 or 47.12.
Sorry.
So omega L value is, I got as 471.2. It is 47 or
Oh, is that so?
421.
Let me calculate. 120 into pi into 125
Oh,
divided by 1000, because it is 10 to the power minus 3. So it is 15 pi, right?
Yes, ma'am.
So
Yeah, yeah.
47.12. No, it's like 47.12 only. This is pi. I don't know if you like you considered this, right? So it is
No, no.
one.
I made a 1 2
Oh,
5
right,
0,
right,
ma'am.
right,
One
right.
zero extra. Yeah.
Right, right. So this is 125 millihenry.
Yes.
Sorry. Like, is it clear now?
Yes.
Let me see if anyone has joined. Yeah. Okay. So it's 75 minus 48.22. So it is around 1.1 J, right?
Yes.
Okay. So we have the impedance now. So we can, let me see if anyone else is also there. Yeah. So now that we have the impedance, we can calculate the phase current. So this is for each phase. So the phase current will be V phase by Z. So um, we are given the line to line voltage here, VL. So we can calculate the like phase voltage also from here. So the phase voltage in case
Yes.
of star connected network will be how much times the line voltage?
Root 3 times. Root 3 times the line.
Yeah, it will be like the line voltage is root 3 times phase voltage. So we can
Yeah.
calculate
Yes.
this 400 by root
Meet.
3. So this comes out to be uh, 230.94. Okay. Um, so and the since there is no phase is given, the phi is 0, so it is you can write this 230.940 degree, right?
Yes.
Yeah. So for the phase current we can calculate is 230.940, and z we can write it in like terms of like z can be written in magnitude of z times the angle, whatever be it. So if we just write it like that, so let us calculate the uh, magnitude of this. So it will be square root of so the magnitude of z will be square root of
R
75
square
square
plus
plus, yeah, r, r square plus x c minus xl whole xl minus xc whole square. So it will be like this: 75 square plus 1.1 square, something around 75.008.
0 is nothing but 75.
Yeah. Now the angle will be, let's calculate, tan inverse of, so you can calculate the angle, right? Theta will be tan inverse of,
Tan what?
huh,
1.2.
right. So the cos part and the sine part by 75. So it comes out to be
0.8.
minus 0.84. So writing it here 75.008, angle is minus 0.84. So 230.94 divided by 75.008. So the phase current comes out to be 3.0.
3.07.
0.788. And what will be the angle? This is 0 divided by, this is minus of 0.84. So what will be the angle? See, if one, for multiplication, if let us see if it is theta 1, let us say this is z1 theta 1 and it is multiplied by z2 theta 2. This is the angle. The magnitude will be z1 z2 times theta 1 plus theta 2.
Plus theta 2.
Yeah, and if it is divided by this z1 theta
Minus.
1 by z2 theta 2, so it will be z1 by z2 whatever the magnitude be, and theta 1 minus theta 2. So in this case this
Yes.
will go up and be
0.84.
right. So we have the phase current. Now the total power that will we need it in watts. So watts suggests that we only need the resistive power in the circuit, because you know the relation, like the imaginary part of the power will be given in kilovolt ampere, right?
Okay. Yeah.
kVAR, right?
Yes.
Watts is the real power, and volt ampere, this is the apparent power. This is the magnitude of these two. So we need only the real power in this, calculate the real power in this case. So power will be equal to so it will be I square R, so I phase square into resistance of each phase
Ah,
square. Now there are three phases in the circuit, so it will be summation of all of them. So since all of them are equal, it will be 3 into I square phase, right?
yes.
Yeah. So I we have it here. So it will be 3 into uh, 3.0788 square. The angle will be 0.84 and R value is 75. Sorry, I don't know why I wrote this square. So yeah, I square R, right? So 75. So whatever the value this be, this, and okay, yeah, so the current, so for the current, uh, we take the magnitude of it, right? For the power, we will take the magnitude of the current, right? So we
Yes.
don't need this. So it will be into 75 into 3. So 3.0788 square into 3 into 75.
2131 watt.
Yeah, 2132.7 watts. So this comes within this, the range which is given in option A. So the correct answer is option A. Everyone got this right? The others also? If yes, we can move to the next problem.
Yes. Yes.
Okay. So for the next case, a circuit which has three-phase, three-wire system with a line voltage of 500 volt is given. Now two balanced three-phase loads are present. So it's not just one load, two loads are present. One is delta connected capacitive load with this much impedance per phase, and the other is a star connected inductive load with this much impedance per phase. It is observed that the three phase system altogether supplies power, like which is in kilowatts. So again we have to find the real part of the power at some power factor. So we have to find both the real power and the power factor. So in this case, like the circuit is kind of like, there is two loads given, right? So one is star connected and so it is connected to whatever the supply may be. So with of course there like the neutral I have not drawn here, and there is another load connected which is delta. So delta will be, there is some here something, whatever the reactance be. So yeah, um, so this is connected to this. So the circuit is somewhat like this. And for the star connected load, it is given each branch has 6 plus j into 18, and this is the capacitive load, which is 24 minus j 18, right? So Z1, Z2, let it be like, okay, then again in delta capacitive load, this is per phase. So now one is star, one is delta. For ease of our calculation, uh, we will transform any one of this, either the star one we will convert it to delta, or the delta one to the star. So I'll write it with a different color. So instead of this delta, we will convert it into a star connection. In our previous classes we had seen the star to delta connection, right? Especially when all the at that time we did it only for the resistance. So if all of them are equal, so its equivalent star will be the, suppose for example in R we used to go by R delta by 3, right?
Yes, ma'am.
So similarly here in case of Z, we will be Z star will be Z delta by 3. So let us do it. Mm. E, so for each phase it will be, where did my pen go? Yeah.
8 minus
So it is 8 minus 6j, because it is given
yes,
24 minus 18j. So divided by 3. Okay. Now
yes,
the, for each phase, what will happen is the branches will be connected in parallel with each other. So per phase there will be one from one of the load which is previously connected in star, 6 plus j into j plus j into 18, and there will be another one which is connected here having a capacitive load of 8
8
minus
minus
6j.
6.
So in each phase the impedance will be this parallel with this. So okay, so the total Z phase will be 6 plus 18j parallel to 8 minus 6j, right? So we can calculate this, right? 6 plus 18j multiplied by 8 minus 6j by 6 plus 18j plus 8 minus 6j. So it will be 48 minus
9
36j plus 8 into
plus
18.
144J
Right. 144j.
plus 60
This will become plus because this like j and j square will be
square.
negative, and this is one negative, so it will be plus 18 into 6, so 108 plus 48, so it is 156. 156 minus 144 minus 36, 108j, right? So can you just simplify this and tell me what is the value? Like, it is just normal simplification. You have to multiply this with this divided by this. or let me calculate 14 into 156 divided by 14 plus it is 108 into 12 divided by it is 10.23. The real part is 10.235 and the imaginary part is 108 into 12 plus 156 into 14 divided by 12 square plus 14 square. 1 point. So this comes out to be minus j into 1.0588, something like this. Okay. So you can calculate it and check it whether this comes or not. So now you have the Z phase, like for each phase you have the impedance. So you can calculate the current and like the current will be, uh, where do I write it? So yeah, phase current will be phase voltage by Z phase. Now the line to line voltage is given here, which is given as 500 volt. So the phase voltage will be, since it is given it
Real
like,
by
yeah, VL by root 3. So 500 by root 3. So it is
288
288.68.
point.
Yeah. And the angle is 0. So you have the V phase. Now if you calculate the I phase, it is 288.680, and Z phase we will write it in terms of the angle, then it will be easier to divide. So it is square root of 10.25235 plus 1.0588 square. So it is 10.2896, and the angle will be tan inverse
Point
of, yeah, tell me what will be the angle?
tan inverse of point double 1.0588 by 10
By
into
10.235. So it is 5.906 angle. 5.906. So we have this divided by 10.289, angle is 5.906. So just calculate this and get the I phase.
20.056.
Yeah. So yeah. So it is 228.05. 28.05, and the angle here it will go up, so it will be 5.906. So now you have the I phase, and since you need only the real part of the power, so the real part of the power will be I phase square times R. So it is 28.05 square times R here is, uh, so Um, so it is 6 and 8, right? But so instead of calculating it again, so in this case you see uh, the z phase here, so this is the magnitude, right? So when like if z is given in terms of suppose z magnitude times the angle, so it will be z into cos of theta plus mod of z into sine of theta. This will be it, right? So basically this part is your resistive part and this constitutes of your inductive and capacitive part. So you can simply take this to be your phase resistance, right? 10.2535. So 10.2535, whatever comes out is the total power in kilowatts. So it is 28.05 square times 10.2535.
8056.
Sorry, yeah, here, sorry. So it comes out to be 8067. Now this is of one branch. So we the total power will be 3 times of this power, right? So the power total will be
Yes.
3 into 3. So into 3. So 2420, 24.2, 24 point around 2 in terms of kilowatts. If we write this will be 10 to the power 3 watts, so in kilowatts it will be 24.2, which can be either this or this. Now what is the power factor is cos of the angle between voltage and current. So here the angle that is coming up in like here is 5.96. Here the current, this is the this is I phase, right? So the current has an angle of positive, that is 0.96, and voltage is 0. So basically in this case, if this is the voltage vector, the current is leading the voltage. So in this case the power factor will be leading, right? Because the current is leading the voltage, right? Did you get it? So the correct option will be like 24.2 is approximately 24.17, but the power factor, since current is like the angle here is positive and it is leading the voltage, so it will be a leading power factor. Everyone get this one?
Ma'am, how is that leading? Just once, can you explain? Actually, your voice broke at that middle, whatever you're talking.
Okay, so the current angle that we are getting, the phase current angle is positive, right?
Okay, okay.
So
Yeah, yeah.
like
Plus for
whenever,
leading and minus for leading. Yeah, yeah.
right, so that means the current is leading the voltage, so the power factor here is positive and it is leading. So power
Yes,
factor will be cos of this angle. So cos of theta is cos of here it comes to be 5.906. So it is cos 5.906. It comes out to be 0.99469.
yes, ma'am.
So there are two options, leading or lagging. Since the it is positive, the current is like the angle is positive, the current is leading the voltage, so it is leading power factor. Okay?
Yes, ma'am.
Okay. If everyone is okay with it, we'll move to the next problem.
Yes, ma'am.
Okay. Um, in the next problem, we have a star network here with a neutral line, and it is said that like a three-phase load is connected to a three-phase balanced supply as shown. here all the impedances are marked in ohm, VAN. This means this is the phase voltage. It is given with respect to neutral. So phase voltage is given, Bn is given minus 120, since all the three phase voltage is 120 degree apart, like with angle from each other. So, and this is 200, 120 degree angles are considered to be positive in the anti-clockwise direction. Find the total active power W in watts supplied by the three-phase source if the current in the neutral wire is 0. So the current here is equal to 0. There is phase current that is flowing through each of the branches, and one of the branch is resistive, the other has a capacitance, and the other one has a inductance. So this is not typically what you have seen earlier. Here the three branches are like different, has different elements. So here what you can do, since we can apply KCL at each, like any circuit at a particular node, KCL is valid. So let us just apply KCL here. Let us say this is the phase current AN, let this be IBN, let this be ICN. So since it is given in the question that in the neutral there is no current flowing in the neutral wire, so here it is I is 0. So basically IAN will be equal to IBN will be equal to ICN. Now why we are doing this? Because this resistance is unknown. Until we calculate this resistance, we cannot calculate the total power. The total power will be actually the power that is, since we have to calculate it in watts, which means we have to calculate the only the power of the resistive circuit. So only this branch we have to calculate. The other is purely inductive and purely capacitive. So we won't get real power here. So only power we will get is in this branch R. Now R is unknown, so we have to first calculate that. For that we are applying KCL at this particular node. Let's say this is the node N. Okay. So sorry, this plus this will plus this, by using KCL, this plus this will be equal to 0, right? So we are more interested in this branch. Let's see if someone has joined. Yeah. So yeah. Uh, since we are interested in this particular branch, let us just calculate AN first, right? Because the phase voltages are given. So if we have the phase current also, then voltage by current we can calculate R. So let us calculate IAN in terms of IBN and CN. So it will be minus of IBN minus of ICN. Now the current in this branch will be the voltage in this branch divided by the total capacitance or inductance, whatever that might be. It is, since all these are given in ohm, it is given somewhere in the, yeah, it is given in the question, right? These are in ohm. So it will be minus of VBN by ZBN plus VCN by ZCN. So
Yes.
in this case, like we have for VBN the voltage is 200 and the angle is minus 120. So 200 minus 120. These are all the phase voltages, since they are given with respect to neutral. So we don't have to divide by 2. And what will be ZBN? ZBN is equal to minus J10, right? Sorry, this is C. So this will be C. This is B. So this will be B. So ZBN is actually the inductive one, so it is J10. So divided by J10 plus VCN is given as 200 angle 120. So 200 angle 120 by minus J10. Now instead of writing this in J, we will just write it in terms of angle. So it is 200 minus 120 And what will be the angle of a purely inductive circuit? So the magnitude will be 10 only, right? What will be the angle since here? Can you comment on the angle? What will be the angle of a pure,
90.
huh? So see, yeah. So here the it can be written as 0 plus j10, right? So tan inverse 10 by 0. So this is basically tan inverse of infinity. So it is 90 degree. Clear, right?
Yes, ma'am.
And for this it is minus, so it is minus infinity. So we'll have to write it in terms of either like this minus 90 degree. Is it fine? Or since you can do both ways, you can convert it to angle and then for adding up you have to split it in j anyway, or you can directly split it in j from this step itself. If it is whichever seems easy for you. For example, instead of writing 200 minus 120, so you can write 200 cos of minus 120. So cos minus 120 is minus zero point 0.5, right? 200 into minus 0.5 plus j sine of minus 120. So sine minus 120 is minus 0.866. So this will become minus 0.866. Since you have to add here anyway with the other component. So we can write it this way also. 10j. Then so it will be again, let us take the 200 outside, so that 200 by 10, let us take it outside. So we don't have to write it here. So 210 we have taken outside. So again cos of 120 will be minus zero point 0.5 and sine of positive 120 will be j 0.866 divided by this will be minus j. So we can even take the j outside. 20 by j is equal to, so there is a negative sign outside, right? Yeah. So minus zero point 0.5 and here minus it will be plus. So it is 1. This is minus 0.866 and okay, this will be plus, so this will be 0, right? Yeah. So this is minus zero point 0.5 and this one will become plus because there is a negative sign in the denominator, so it will be 0. This is negative, so j 0.866 into 2, right? Because this will also become negative. So it is 20 by j into 2 into 0.866. So j. So j you just get rid of. So the total will be 2 into 20 into 0.866, which is 34.64. So you have now calculated IAN. IAN is 34.64. So you can either directly calculate the power factor by multiplying V into I, or you can compute the resistance if you want by dividing V by IN to compute resistance and calculate using I square R. Since we already have the phase voltage and phase current, and this is, we have to calculate only the real part of it. So let us just calculate it. 200 it is given here. For the phase A, the angle is 0. So 200 times I is 34.64. In this case, the resistive is only one branch, right? The rest of the branch is not resistive, so we won't get real power out of it. So there is no multiplication by 3 because it's just one of the branch which is resistive, which is contributing to the active power. So it is 200 into 34.64, 6928 watts. So it is equal to 6928 watts, which is in this range, option C. So this is the correct answer. Everyone got this one?
Yes, ma'am.
Okay. Then let's move to this fourth problem. So here, uh, for this circuit, you have to calculate the total reactive power. So basically in volt ampere reactives, that means only the inductance in like you have to take the contribution from the three inductance, right? So it is the same thing, only here the sources, two current sources are connected in two different branches. So what you can do is like calculate the contribution from each of this branch and then compute the total current that is flowing in this branch. Then you can like calculate the total power in terms of the current and the current in this branch, the phase current in each of this delta branch, and the uh, contribution from this inductance, right? So it will be like I phase square times the reactance due to L. So to calculate the branch currents, you can either use any of the theorems. So since there are two sources, current sources are given, the easiest possible solution could be by superposition. So we will calculate for one source at a time and then compute the current in this branch. So let us draw the circuit. So first, if we consider only this particular source, the other source will be, the current source will be open circuited. So it will be somewhat like this, the 10 ampere source with 0 angle. So yeah, now this is the inductance, this is the resistance, inductance, resistance, inductance. Okay, yeah, and since this is open circuited, no current is flowing here, so it is almost like one source supplying into one pair of inductance and reactance, and these two are in series with each other, which is in turn parallel with this particular branch. Is the circuit clear? Like let's say AB, across AB this 5 ohm resistance and 5 ohm reactance is connected, and then two sets of 5 ohm reactance and resistance like this, let's say Z1, Z2, which are equal, they are connected in parallel to this particular branch AB, and they are in series, Z1 and Z2 are in series with each other, right? So we can calculate the current in this branch by using current divider rule. So let us just first write what are the currents. So let us write. So let this be the first, second, and third branch. So 1, 3. This is 1, 3 current. And from here also let us assume that a current is flowing. Let this be 1, 1. And the current that is flowing here through this branch, let this be I12. This is due to the first source in the three different branches. So here if you see the current that is flowing here, I will take a different color maybe. Yeah. So the current that is flowing here is also flowing through here because the rest of the circuit here is not connected. So basically I11 will be equal to I12, right? and this current, the total current in this branch through here will be, if you use the current divider rule, it will be in reverse of the resistance, total resistance. In this case it will be impedance. So the total is 3 times of 5 plus j5. Since is in each branch it is the same, so it is basically the total will be this plus this plus this, which is 3 times of this. And the current through this particular branch will be 5 plus 5j, because of the current divider rule. This is the total current. Is this clear? You remember the current divider rule, right?
Yes.
So yeah, so okay, we can then calculate this to be 10 by 3 angle 0. This is I11 and I12. Now the I rest, what is there? This I13. This current is left, right? So I13 will be equal to, again, like 3 times of 5 plus j5, and on top it will be the other branch impedance, so it will be 2 times of 5 plus j5 of the total current. 10 angle is 0, so it will be 2 by 3, so 20 by 3 angle of 0. Now using the other source, this particular source, similarly we can calculate. Here I will just redraw the circuit with only the second source. So yeah, this is the second source. Now the other source is open circuited, so it is like this branch is connected across the current source, and I will take the color. Yeah, and these two resistance and reactance are in series with each other, which is in parallel with this particular uh, this particular impedance, like this particular branch, and here current is 10 120 degree. So again, let us assign the currents here. So let us just say this, like this one, let it be I21, let this current be I22, because of the second source in the second branch, second source in the first branch, and second source in the third branch. So in this case, this I21 and I22, no. So in this case, uh,
I21 and I23.
2 3, this two like this two is supposed to be the same, like the current that is flowing through the same branch, but they are assigned in a different direction. So I23 will actually be, uh, so current here 10 ampere with 120 degree angle is coming here. So I21 will be negative of I23, sorry, yeah. So I23 and I21 will be negative of each other, right?
Yes.
Yeah. Let us first calculate I22. So if the current source here is in this particular direction, I'll maybe redraw it, then it will be better. Sorry. So yeah, this is, and yeah. So the current direction is in this direction. So here 10 120 degree, this current is flowing, and this is getting distributed in these two branches. So this I22 current will be equal to the entering current is here 10 120 degree and again by using current divider rule we can calculate it. So the total resistance will be impedance will be 3 times of 5 plus 5j, and it will be 2 times of this, right? 5 plus 5j, because we take the impedance of the like the other branch. So it will be 20 by 3, 120. Then 2 3 and 2 1 will again be like this 5 plus 5j by 3 times of 5 plus 5j. So I'll just directly write it to be 10 by 3, 120, right? This is fine. Now as like assuming superposition, we have to calculate the total current in each branch. So I will just copy this to the next slide. So total current, let's say in this branch, I1 will be equal to I11 plus I21, like the contribution from both the sources. So where is 11? 11 is given here as 10 by 3 angle of 0. So 10 by 3 angle 0 plus I21 is here 21 is minus of this, like minus 21 is 10 by 3, 120. So it will be minus of 10 by 3 angle 120 degree. So just take 10 by 3 common, and this can be written in terms of like cos, like we'll write it in terms of ax plus bj. So since we have to add it, so cos 0 is 1, sin 0 is 0, so it is gone. And I11, right? So here where is I11 is 10 by 3. So 1 minus of cos 120 is 0.5. So let me take the calculator. So this is positive angle. Ten by 3. 5 j sine 120. Let us just write in terms of like numerator and denominator instead of points. It will be easier to calculate. So here cos 120 is minus half, sine 120 is 3 by 2, right? So it is 10 by 3 times 1 plus half will be 3 by 2 plus j root 3 by 2. Let us take let us take out root 3 from this equation. So 10 by 3 root 3. So it will be root 3 by 2 plus j half, right? So it can be written 10 by root 3 in terms of angle. If we write, what will be tan inverse of half by is will be half by 0.866. So it is 30 degree. Okay. This is the current from this particular branch. Then mm, let us similarly you can calculate I2. I2 will be I22 plus I12. So can you calculate in the similar way? So it will be I22 is 20 by root 3 times 120 plus I12 is 10 by 3 times 0. So just take 10 by 3 outside, and you can calculate this cos 1 like so cos 120 will be minus 0.5, right?
Yes.
So we will write it in, sorry. So yeah, sorry, I think I made a mistake here. It will be minus j, because this minus, this is plus, it will go inside the bracket, so it will be minus. So I guess this will be then minus 30. So again here half minus half plus root 3 by 2 j, and this will be 1. So it will be half plus root 3 by 2j times of 10 by 3. Similarly, if you take root 3 outside, it will be like 10 by root 3 times root 3 by 2 plus 1 by 2j. So in you write in terms of angle 10 by root 3, this will be plus 30 degree. Then for I3 you can calculate. I3 will be I13 plus I23. So I13 is somewhere 20 by 3. 20 by 3 angle is 0, and I23 here is 10 by 3 angle 120. 10 by 3 angle 120 degree. So you can again take 10 by 3 common. 2 times of angle 0 cos 0 is 1, sin 0 0 is 0, so it is just 2. And for the uh, rest again 120, so it will be minus half. So here it will be 2 times, right, in this
Yes.
case, right?
Yes.
Yeah. Yeah, so maybe I'll rewrite it again then, so it won't be this. hmm. So it will be 10 by 3 times, so 2 into 2 is minus 1. So this minus 1 and this plus 1 will get cancelled, so it will be root 3 by 2 times j. So it will be root 3 cancel, 10 by root 3 j, and j is 10 by root 3, angle is 90 degree, right?
Yes.
Yeah. So again in this case 10 by 3, this is 3 by 2 plus j root 3 by 2, take root 3 common, so it will be 10 by 3 root 3 by 2 plus j half. So again, yeah, this comes out to be 30 degree. So these are I1, I2 and I3 you have got now. So now you were asked in the question to what was the total reactive power. So the total reactive power will be I square into, like, I'll take a different color. So the total reactive power will be this
It's
the
correct.
yeah, I1 square times the reactance here. So reactance here is 5 ohm given. So 5 plus I2 square into 5, since in each branch it is 5, I3 square into 5. So can you just calculate? So here in each case the magnitude is 10 by root 3. So it is 3 times of 10 by root 3 square is 100 by 3 into 5. So it is 500.
500.
Huh. So the
Yes.
correct option is option D, right?
Yes.
Yeah. So, like notice, like earlier when I had calculated the wrong, I had forgotten this to take this 2, the angle would have been different, right? So the phase current, you must remember, sir has taught in the lecture, like when you calculate it is, like for each phase it will be minus 30 degree, 90 degree and 30 degree. Sir has shown using the phasor diagram, remember?
Yes.
Yeah, so like in case we make a mistake, we can also revalidate our calculation. So yeah, okay. I hope everyone is okay with this. If yes, we'll move to the next problem.
Yes, ma'am.
Yeah.
Yes, ma'am.
So I don't know who was there. Anyway, so for the fifth question, uh, we have a delta connected load of the total power that is connected is 240 kilowatt up to a line voltage of 1900 volt. Frequency is given taking a leading current of 100 ampere. Leading current means it is kind of a like a capacitive circuit, right? Find the series connected circuit constant of the load phase in the given. The RLC denotes the resistance, return, etc. PH denotes the phase quantity. So you have to calculate the resistance and whatever the capacitance might be in each of this load. So power is given, which is equal to, like, it is given in kilowatt, right? So it is the
Kilowatt.
uh,
Yes.
like the real part
Active.
of the power is given, the active power. So it is 3
Yes.
times each phase current times the resistance in each phase, right? So we can
Yes.
calculate the resistance in each phase. Power is given to 40 into 10 to the power 3, so it is in kilowatt, divided by 3 into I phase. I phase here it is given, it is taking a leading current of 100 ampere.
100.
So this is the line current. We will have to take the like for the delta connected circuit, the line current is equal to, in terms of
3
like
times
root
the
3
phase.
phase current. So here we have to take the line current is given, so divided by root 3 whole square. So this is around, so 2 4 10 to the power 4. Then again here root 3 and this will get cancelled, it will be 10 to the power 4, so it is 24 ohm. So we have the, in each phase we have the resistance. Now the total phase, the in each phase, the since we already have the voltage here, the line voltage is given, we can very well calculate the phase voltage. But in case of delta connected circuit, VL and V phase are the same thing, so we can calculate the Z phase, right? So it will be V
Yes.
phase by I phase. So 1900 divided by, the current is given 100 by root 3. So we have 19 root 3. This is the total impedance. Now this
Impedance.
consists of the resistance and the
Reactive.
capacitive, yeah, reactance. So it will be like square root of this plus this will be equal to Z.
Yes.
So we have 24 square plus we have like we can omega c you can calculate. So omega is given 50 hertz. So it is 2 pi into 50 times c is equal to 19 root 3 square. So you can calculate C phase here, right? Sorry, this will be XC. XC is 1 by j omega C. So it will be 1 by omega C. So 1 by omega into C. So let's calculate this. 19 root 3 whole square. So it is 1083 minus 24 square. 576. 1 by 20 pi 2 pi 50, so it is 100 C. This minus 1083 507. So it is C is equal to 1 by 100 pi into 507 into pi into 507. So uh,
6.27 microfarad.
yeah, 22 point. Sorry. Did you calculate it already?
Yes. Mm.
Okay. What did you get?
6.27 microfarad.
Uh,
But we need to convert into radians per second, no? Degrees per.
right, right. Yeah. This pi needs to be calculated.
Yes.
Sorry. Yeah. Uh, 2 pi f. So we can also like this is the frequency 50 hertz is given, right? Yeah. So 2 pi f. This is fine, right? So frequency 50 is given. Omega equal to 2 pi f. So let's see. Oh yeah, right. So square of this is this much, right? So
Yes.
yeah, so it has to be 1083 minus 574. Square root of this we have to take. So basically 1000 pi c will be square root of this value, right? So it will be 22.56. We took the square root of this value. So C will be equal to 1 by 22.56 times 100 pi. So 1 divided by 22.56 into 100 into pi. This comes out to be 1.41 into 10 to the power minus 4. So if you write it in terms of microfarad, it is 141 microfarad, which is like the R phase comes out to be 24 ohm, and this is roundabout here. The correct option is option B. So we'll do one more problem and wrap it up. So in this case, for this particular problem, a star connected load is given, and in each of this load, parallel resistance, reactance, and and a combination of resistance and uh, inductance is given, and ABC are in phase sequence. The AB, the voltage of between two phases are given. You have to find the current, the line current IA. The line current connecting phase A of the source and the load is denoted by IA. So they are just denoting what line IA current means. So for computing the current, you first have to calculate the impedance. So since all of them are said to be connected in parallel, so we can calculate it as J50 plus 1 by 50 plus 1 by 25 plus J25. So let us calculate this one. um, 25 into 25 square plus 1 by 50. If we take the j to the numerator, so it will be plus sign will go, it is by 50. So let us take uh, let us take 125 outside and 2, so 50 we will take common, so it is j plus 1 and 125 will be remaining, so it is 25 minus 25j by 25, so it is 1 by 50 j plus 1 minus plus will be 1 minus j, so j will be cancelled, it is 2 by 50, it is 1 by 25. So Z will be actually purely resistive. So Z is equal to, where did my cursor go? So Z is equal to 25 ohm, because this is inverse of Z, right?
Yes.
Uh, so now voltage A is given, like VAB is given to be 400 angle 0, and we have the, so we can calculate the IAA, right?
Yes.
So
Yes.
it is VAN by Z of each phase. So we have calculated the Z of each phase. So since it is given a star connected load and we are given the line voltage, so it will be 400 by root 3 by 25. And okay, so yeah, VAB is given. So sir has actually like, I guess, taught in the class, if you remember, like if each of this angle, like V C, and so in VAN, VBN and VCN will be 120 degrees apart,
What was
and if you have to calculate VAB, VAB is actually the resultant of these two. So if you simply right, so this will be minus of VBN, so the resultant will be somewhat in this direction, so this angle is 30-degree, right?
that?
Yeah, so
Yes.
this will be like for the A phase it is minus 30-degree, for B it is 90, and C it is plus 30. So the angle will be here. So 400 by root 3 divided by 25, 400 divided by root 3 divided by 25. So it is around 9.237, and the angle is minus 30-degree, right? So this is the option B is the correct answer. So I guess we have finished our class time. Yeah. If you have any doubt, you can ask. Otherwise, we can stop it for today, and we'll meet in the next interaction session.